So, hello students. Uh, we just finished physical world chapter of the first PU. So, as you can see, there is a lot of data, a lot of information given in the NCERT textbook. This itself is the NCERT textbook. So, there is a lot of things here given, and so many things here I did not explain. I just left them. Okay, this part especially scope and excitement of physics. Okay, the reason I left them is, see, this is somewhat like the introduction of the same concept which you are going to study in the coming chapters. Okay, whatever you have here, okay, all will be studied and understood in detail uh, when we complete the entire course. So I don't want to give, say, it is just about, I could have just mentioned these things, but that would not give you the detailed idea about these beautiful experiments and all. Okay, this one, Rutherford's one. Okay, all of them we will study. Okay, nothing to worry. You won't be left behind, or I won't leave all these things. I will cover all of them. Okay, we will discuss everything in detail by the end of the course. And if I now try to explain you these things, it will consume a lot of time and effort. But at the same time, and at the same time, these concepts which I have left are not asked for your board examinations, not even for the competitives. No need to worry. Okay, because when it comes to competitives, we will discuss all of this in detail by the end of the course, so no need to worry about that. And when we come for boards, there we have uh, these things not coming, not appearing for the board examination. So all these things, physics, technology and society, and this one, scope and excitement of physics, no need to bother about those things. Okay, anyhow, we'll cover most of them, and things which are not covered will not be coming for your board examination. Okay, because what we follow, the Karnataka PU board has given its own pattern of syllabus, which is called blown up syllabus. In that, according to the blown up syllabus and the question papers that appears regularly, we don't see these kind of questions appearing. Okay, anyhow, we'll come back for that once we complete the syllabus. We'll cover them, no need to worry. But this is very important, which I must explain, just give you the glimpse and close the chapter. See, here you have table 1.1 from page number 5 of your NCERT textbook, Physics Volume 1. Okay, this table 1.1 is very important for 1 mark question. So here you have major discoveries or contributions given by proper scientists and with their corresponding country. So here it would be little difficult for you to memorize everything. Okay, but I advise you to at least memorize the name of the scientist and major contribution. Don't need to bother about the country to which the scientist belongs to. You just memorize name of the scientist and his discovery or contribution. Okay, this list, what you have, approximately 30 inventors with their inventions. This list is important. Okay, with their inventions. For example, you might be asked a question like, who discovered neutron? It's James Chadwick, right? Or they could also give you the question like, what is the major contribution of R.A. Millikan? So its measurement of electronic charge. Okay, famously known as Millikan's oil drop experiment. So like this is how you can be asked with the questions. and just memorize them. Don't need to bother about the country. You just make sure that you know who discovered what. Okay, that's it. You just go through them once. You can find this book, NCERT textbook, online. Okay, chapter wise. There are many sites, and the official site of NCERT also provides the textbook. You can go there and download it. Okay, if you do not find, you just text me. I'll forward you in WhatsApp. So, and write them down, memorize them. That's enough for the first chapter. And now we'll go for the second chapter, which is units and measurements. Okay, yeah, all those things, even this steam engine, yeah, this is also fine. There is one more table I just forgot to mention, table 1.2. okay, the technology and the corresponding scientific principle involved in it. Okay, just go through them once, but as of memorizing is concerned, you must concentrate on memorizing these things. Okay, the names of the scientist and major contributions, memorize them well. Just go through them, go through the other table, just go through it. Okay, if you find enough time, you just memorize them. That's enough. So yeah, all these things we have discussed, and now we'll go for the second chapter, units and measurements. Hello everyone. Today we shall take, since we just finished the first chapter, physical world. Okay, don't need to bother about the rest of the things in the NCERT. You just stick to what I am teaching. Okay, that would be enough for your boards. And wherever extra things are necessary for competitives, okay, there and all, I'll inform you about that. So whatever I taught you in the first chapter is enough for your boards, and nothing is asked from that chapter for your competitives. So nothing to worry more about that. Let us move ahead with the next chapter, units and measurements. So units, in this is the actual name should have been like units, measurements and dimensions. Okay, so because it has basically three parts in it. The entire chapter has three parts: units, measurements and dimensions. So first we'll take units part. Okay, so we'll be taking units part today. See, whatever we find in nature physically, we always try to measure quantities, right? If you are given with say this much of water, okay, in a bucket, okay, say this much of water in a bucket, you are given with certain amount of water, right? You have that much of water with you now, and you are asked to measure the water. Okay, then one might start thinking like, okay, fine, I have water, I can measure, but which quantity of the water should I measure? Isn't it? Because I can measure volume of water, so and so liters, 5 liter, 10 liter, right? That's right. I can also measure mass of the water. I can take that much of water, keep it on top of a weighing scale, and I can get the weight of water or mass of water. That's not it. I can also measure the temperature of water. I can take a thermometer and keep the thermometer inside it and get the temperature of the water. And I can also get the pressure of the water or pressure on the water. There is an instrument called barometer. We can make use of it and get the pressure. So this is one substance, and we can measure many quantities of that substance. So similarly, we find so many different physical quantities for different physical substances, or we can say sometimes substance, sometimes it can be energy, right? Like if you are given with a bulb, light bulb, and if I ask you to measure the bulb, you will again start thinking, what should I measure with the bulb? there are so many factors to measure with the bulb, a light bulb. What and all? One is intensity of light, how bright the light is, how dim the light is. The intensity of light can be measured, and the frequency of waves coming out of it, right? They're all electromagnetic radiations, you know that. Light wave has 7 colors in it. So I can also measure the frequency of the light, intensity of the light can be measured like this, and I can also measure the temperature of the light, right? So any device, any substance and any form of energy can have various physical quantities which can be measured. That is all big examples. Water is one easy example, and the other kind of examples that we see is you go to market, there you ask the vegetable seller, give me a kilo of lady fingers. So then he gives, okay, and you go to the other section of the market, there you ask the seller to give 1 liter of milk, right? You don't ask milk in kgs, and you don't ask vegetables in volume, right, in liters. So different substance, according to the situation, depending on the situation, has got a different kind of measurements, okay. So in this chapter we are going to discuss in detail about different kind of measurements, different kind of quantities that we have, different kind of units that we make use of to measure all those quantities, okay. So let's begin with quantities, physical quantities, okay. Everything that we can measure is a quantity, right? We can measure so many things, all of them are all physical quantities. We'll begin with the classification of physical quantity, directly begin with the classification of physical quantity. So first type of physical quantity is called fundamental physical quantity, okay, fundamental physical quantity. So, or fundamental quantities in simple, both are one and the same, okay. So what are these fundamental physical quantities? As I said, there are so many quantities which we can see in nature, but there are few factors or few quantities which are dependent on other quantities, and few quantities which are not dependent on any other quantities. As an example, if I ask you to measure the speed of a moving object, you should first measure the length of the object that moved and the time taken for the motion. Then you can get the speed by putting it into the calculation of distance covered by time taken, okay. So that is how velocity is a physical quantity which is dependent on distance, which is again another physical quantity, and time, which is one more physical quantity. So velocity is dependent on distance and time. So this is a quantity, velocity is a quantity which is not independent, okay. But you take distance and length, or I can say distance and time, okay, or in other words length and time. Distance, instead of distance I will make use of length, okay. If I take length and time, see, I don't want any other quantity to measure the length. Similarly, time, I don't want any other quantity to measure the time, right? Yes, obviously I need few instruments, few devices like stop clock or even the regular clocks, mobile phones, everything, all those things are required to measure. They are all the instruments that we are making use of, but the quantity, length and time does not depend on any other quantity, isn't it? So there are few quantities, okay, which are not dependent on any other quantities. Now let me take another example of, say, volume. So and so liters I can say, but when I say liter, it is actually length into length into length, or I am just simply taking the quantity. I am not going particularly to the formula, I am just taking the quantities, right. So volume is dependent on length. If we know the length, then only we can get the volume. And in the same way, area, okay, length into breadth is the area of a rectangle. So I can get the area if I know the length and breadth. So length and breadth are again lengths, okay. So area is a physical quantity which is dependent on length. So fundamental, they are also called as basic physical quantities, okay. So now I hope you have a kind of clarity, where fundamental physical quantities are those physical quantities which, okay, fundamental physical quantities are those physical quantities which do not depend on any other physical quantity. They are independent. Any other physical quantity, okay. So that is about fundamental physical quantity. I hope now you have idea about it. Few examples for that, okay. We basically have 7 fundamental physical quantities. We will discuss all of them, but before that I would like to give few examples here, which is length, time, mass, etc. Okay. Again, one more example to make out the difference between fundamental physical quantity and derived physical quantity. When I take density of an object, density is given by rho is equal to m by v, right, mass by volume. So in order to get the density, we must have the idea about mass and the idea about volume. So density is dependent on mass and volume, right. So but here mass is independent. You can directly measure the mass. Mass is not dependent on any other quantity, right. So mass is basically a fundamental quantity, but density is not a fundamental quantity, which is called a derived physical quantity, okay, because it is dependent. What is dependent? Density is dependent on mass and volume, okay. So this is one type of physical quantity. The next type of physical quantity that I am going to take now is called derived physical quantities. Okay, now these are the quantities, the derived physical quantities, which depend on fundamental physical quantities, okay. Yeah, there are many quantities which depend on other derived quantities also, okay. Okay, first let me give you the idea. So these are the physical quantities which depends on the fundamental physical quantities. So example for them, I have given so many examples till now. One of that is velocity and density, area, etc. So all of these are again quantities, but these quantities are dependent on these quantities, the fundamental quantities, okay. So that is about two types of physical quantities that we have. One is fundamental quantity and the other is derived physical quantity. Here, see, there are other quantities from derived physical quantity which are dependent on, which are not directly dependent on fundamental, instead they are dependent on derived itself. Let me give you an example. See, the expression for acceleration, okay, acceleration of an object is v minus u by t. So acceleration is dependent on two quantities. One is velocity and time. Okay, don't worry about the exact formula, initial velocity, final velocity, all those things, don't bother about this. What we should be looking for is the quantity and what kind of quantity it is. Right. So A is equal to V minus U by T is the formula. Acceleration is dependent on velocity and time. So once the acceleration is dependent, yes, it is a derived quantity, fixed, there is no doubt in that. Acceleration is a derived quantity. But according to the definition, acceleration is should be dependent on fundamental quantity. But here we have acceleration dependent on velocity, which is a derived quantity itself. So if you look at that in that way, it is going to be further you can actually elaborate this velocity expressions. Okay, so this velocity is distance by time. So it is somewhat like distance by time squared, right? So now acceleration is dependent on length, or distance is nothing but length, and acceleration is dependent on time, which are fundamental quantities. Okay, so any derived quantity that we take are always dependent directly or indirectly on a fundamental quantity or few fundamental quantities. Okay, so that is about fundamental quantity example, derived physical quantity examples. Okay, so now we will see regarding units. Let's go for that. Okay, next is units. See, we have so many quantities here, okay, so many of them, and we need to measure them. See, whenever I ask you to measure something, what do you need? You actually need a reference, right? And you multiply that reference so many times to get the measurement. Just to give you an example, say if you are given with a stick, okay, of certain length and asked to measure the length of a classroom, then what you will do is you will take the length, you will take the stick and measure the length of the classroom so many times of the length of the stick. One stick, two stick, like this, one stick, 2 sticks, 3, 4, 5, so on, right? So this is how we choose a reference for any kind of measurement that we do. Similarly, when you eat, it's always a spoon which is taken as reference for the amount of food that you consume, right? 1 spoon of food, 2 spoon of it, 3 spoon of it, like that, 1.5 spoon of it, isn't it? So every time we measure something, we always have a reference. But the reference that we have can differ from one country to the other country, or one nation to the other nation, one region to the other region. And we also have our own indigenous way of measuring things. One is, you might have observed, even today, when you go to flower market, the seller does not don't make use of the meter scale, isn't it? You always go for a length of 2 arms, like this, right? So that is the basic reference that we have to measure the flower. If the seller's hands are wide, then yeah, you can get good quantity of flour. If the seller's hands are short, then you can get less quantity of flour. So there we have a reference 2 arms length, but the reference is not a standard one, right? It can vary from person to person. And even when we have standard one, the standard itself, like what we have a meter scale, once again we have different units for same quantity. For example, we measure the length in foot, we measure the length also in meters, we also measure the length in centimeters, we also measure the length in kilometers. So there are different units for the same quantity also. So what is this unit basically? Units are the arbitrarily chosen basic reference, okay? They are arbitrarily chosen, okay, arbitrarily chosen, internationally accepted. Why? Because they should be standard, they should be recognized all over the world, internationally accepted basic reference. Okay, it's a reference basically, nothing else. Basic reference. Okay, basic means it should be available easily, and it should be everywhere like that. Okay, reference chosen for the measurement, chosen for the measurement of a physical quantity, okay, of a physical quantity is called unit or unit of that quantity. So this is the definition of unit. So the reference that we choose should also be arbitrary. What is arbitrary? See, now a certain country, say some other country like some Western country, European country, they always make use of pounds and foot for as the basic reference, right? So they have their own way of measuring things, and here in India we have both. We make use of foot, pounds. We also make use of kilogram and meters for the length, right? So these units should be arbitrarily chosen. Arbitrarily chosen means it should not be, say, our system of units should not cause a problem for the other countries, okay? That is what is arbitrary, okay? Somewhat like kind of comparing, okay? Like they don't want to make the calculations difficult once you convert from one to the other like that, okay? So that is why the units should be arbitrarily chosen. Arbitrary is a term which is somewhat like if two persons are quarreling, then they compare with each other with certain agreements between them, right? That's how these things are. Two countries, two regions, when they have different units, they need to set to one unit by choosing arbitrarily, so that no one loses, or no one is benefited. I mean, both of them must be benefited, no one gets into loss, okay? That's how it should be chosen. So arbitrarily chosen, internationally accepted. So these units what we are going to discuss now are all internationally accepted, okay? So this 2 arms length is not internationally accepted, so we are going to drop that as a standard unit, okay? So arbitrarily chosen, internationally accepted basic reference for the measurement of a physical quantity is called unit. I hope you have the clarity about the definition. Okay, I have explained in detail, but this is what you should remember as of the definition is considered. Okay, moving ahead, we have three types of units followed in the world. Okay, now after 1971, in the conference on the measurements, we all adopted a standard system. Okay, one simple system for the entire world. But before that, we had three systems of unit. Okay, so currently we are following one, and before this standard unit came into existence, we had three of them. Okay, we will see what are the different systems of unit that we have. Okay, so the first system of unit that we have is CGS system of unit. Okay, keep this in mind. Every time we write the name of a unit, the first term of the unit or the first letter of the unit always represents length. Okay, unit of length. The second letter represent unit of mass, and the third letter represent unit of time. Okay, so it is length, mass and time. Length, mass and time. Okay, right, now you see C is the unit of length, which can be centimeter, right? So centimeter is the unit according to, centimeter itself is the standard unit according to CGS system. At the same time, for mass, see you have G, what it might stand for. It can stand for gram, right? So gram is the standard unit of mass according to CGS system. Guess what it should be for time? S stands for, yes, you are right, second, seconds or second. Okay, gram, second. Next, we have one more unit, one more system of unit, which is called FPS system. What is FPS? F stands for foot. Okay, length is measured in foot. Mass, the letter is P. What do you think? Yes, it is pound. Okay, foot, pound, yes, again stands for second. That's it. Okay, foot, pound, second are the units of length, mass and time according to FPS system. And then we have one more unit which is called MKS system. According to MKS system of unit, M stands for mass, M is the unit of length. Okay, M is the unit of length. What do you think it is? C for centimeter, F for foot, M meter. Okay, K gram, pound, what is left? Kg, kilogram, right? Kg is the unit of mass according to MKS. Time, nothing else, it is second itself. So this is how, based on the measurements of length, mass and time, based on the units chosen for the measurement of length, mass and time, we have three system of units: CGS system, FPS system and MKS system. Now, as I said, after the year of 1971, in the general conference of weights and measurements, we then moved ahead, okay, to a standard system which shall be followed throughout the world, and the system is called SI. Okay, we should actually keep it simply SI. if you take the elaborated form in English, it is going to be International System of Units. International system. International system. Okay, so you can ask, okay, here it is IS, it should be, why is it SI? Okay, it's not actually properly from unit. Okay, it's some other language which is actually elaborated as Systeme International. Okay, Systeme International. Okay, so that is this is the system which we are currently following, and according to this SI system, okay, we repeatedly say SI system of unit, SI system of unit. We should actually stick with SI, okay, but again for the sentence sake we keep on adding system again. Okay, so according to SI system, length, see, most of the things are same as MKS system. Okay, where the many units are from the MKS itself. Little modifications are done, which we will discuss in the coming classes. So length is measured in meter and mass is measured in kilogram. Time is measured in second. So this is the unit which we will be sticking with for any kind of scientific calculations that we do, or any kind of measurements that we do in the coming chapters, even in the entire course. Okay, we should be aware of all the different units, but this is the standard unit which we will be following. Okay, right. So this is about in total now we have 4 systems of unit: CGS, FPS, MKS, SI. Okay, these are the one which we followed from many years, but SI came into existence after 1971. Okay, yeah, in some references they have given it as 1961 in, I think, in chemistry, but in physics text it is 1971. Now let me check it once, or you check it once. Okay, so that is about, that's fine, let us stick with what is there in the NCERT. So that's about units and different types of units, or not types, it is systems of units. Okay, because types we have different classification. Again, these are the systems of unit. In SI unit we have 3 classifications again. Okay, or we call them as 3 class of SI units. Okay, so 3 classes of SI unit. What are they and how are they classified? We will see now. Okay, so we already have discussed about 2 types of quantities, fundamental and the derived, right? In the same way here, the units chosen for the measurement of fundamental physical quantities, okay, the SI units chosen for the measurement of fundamental physical quantities are all called fundamental units, and the units which are chosen for the measurement of derived physical quantities like velocity, volume, density, etc., are all called derived physical or derived units. Okay, they are the 2 classifications. One is fundamental unit and the second is derived unit. Okay, there is one more classification which is called supplementary unit. We will see them in detail now. Let me first take fundamental unit. Okay, see, the units which are used for the measurement of fundamental physical quantities are called fundamental units. That's it. Okay, now which are the fundamental units that we have? We only have 7 fundamental units and 7 fundamental quantities. Okay, let us see which are the 7 fundamental units and quantities that we have. So it's length, okay, mass, See, what I am writing here is the mnemonics of that. LMT talc. This will give me the idea about all the quantities: length, mass, time, temperature, amount of substance, luminous intensity, current. What current? Electric current. Okay, these are the 7 fundamental quantities. Okay, these are 7 fundamental quantities, and for these 7 fundamental quantities we have 7 fundamental units. Okay, let us see which are the 7 fundamental units that we have for all these fundamental quantities. Okay, now length. When I take length, the unit chosen, the fundamental unit chosen for the length, for the fundamental quantity length, is meter. Okay, so it is meter which is the fundamental unit of length, and for mass we all know it is kilogram. For time, seconds. Okay, yeah, there are certain rules for writing these units. Yeah, we will discuss them. And when it comes to temperature, it is Kelvin. Okay. For the amount of substance, it is mole. And for luminous intensity, it is candela. And for the electric current, it is ampere. Okay, and we'll also see the symbols for these units. Okay, unknowingly we use a lot of symbols for different units, right? Okay. The symbol for unit meter is simply small letter m, and for the kilogram is kg. Okay, so both small. For second is simply s, small s. For Kelvin it is capital K, simply capital K. For mole it is simply mol. Okay, mole, mole is the unit of substance, mol is the symbol for the unit. Okay, these are the symbols used for these units. For candela it is CD. Okay, CD. For ampere it is capital A. So these are the units and their corresponding symbols for these quantities. Okay, so you should remember this table. This is very important. All you need to remember these quantities first, then they will come, the rest will follow. What you need to remember is length, mass, time, temperature, amount of substance, luminous intensity and electric current are the basic quantities or fundamental quantities. These are their units and the corresponding symbols. Okay, try and memorize them. Okay, they are important, and this is about fundamental quantity. Okay, next, all the fundamental quantities and their units. And now as I said, we have one more type of quantities which are derived physical quantities, and the units which are used to measure the derived physical quantities like velocity, temperature, velocity, density, area, volume. Okay, the units which are used to measure derived physical quantities are called derived units. Okay, very simple. If you are measuring fundamental quantities, these are all fundamental units. Okay, meter, kilogram, second, Kelvin, they are the fundamental units. When I take derived units, The units chosen for the measurement of derived quantities. That's it. Which are the units? We can get so many number of units. Okay. As an example, let me take velocity. Okay. What is this is the quantity. Velocity is the quantity. What is the unit of this quantity? Derived unit of this quantity is meter per second. We'll also write in negative power or meter per second. Okay. Next, we have area, and the derived unit of area is meter squared. Similarly, we have density. Okay. Density is mass by volume, which is kg per meter cube, kg per meter cube. Okay. So like this we can give so many examples. We are going to discuss so many of them in the coming chapters. Okay. We will find so many quantities and so many units like stress, strain, Young's modulus from few chapters, and from other chapters force, pressure, power, work, energy, kinetic energy, all those things has their own units, and we will discuss them in detail when we go to the particular chapters. Okay. So far you just remember the definition of them and few examples. That's enough. Okay. So that is about fundamental units and derived units. Now we will see the other class of unit, the last one, which is the supplementary unit. Okay. So the next class of unit is supplementary unit. There are only two quantities which are chosen, and their units are kept in supplementary units. Okay. The units chosen, okay, units chosen for the measurement of angles, for the measurement of angles. Angles, I am saying, the reason is there are two types of angles. One is plane angle and the other is solid angle. So for whatever we have measured, you have measured till your till the completion of 10th is all plane angle. Okay. Even from now we are not going to bother much about solid angles here. But there exists another kind of angle which is called solid angle. Okay. So there are two units to measure these two types of angles. Okay. And those units are called supplementary units. Units chosen for the measurement of plane angle. Okay. Units chosen for the measurement of plane angle and solid angle. And solid angle are called supplementary units. That's it. So which are those units which are used to measure plane angle and solid angle? Now see, for plane angle, see, plane angle is a quantity. Plane angle is a quantity. See, very simple. What is the angle between these two? 90 degree. So this is some acute angle, this is some obtuse, this can be 30 degree, this can be 120, this can be 90 degree. So this itself is this plane angle, right? And repeatedly I am telling degree, degree, degree. So degree is the unit of this measurement, but that's not the standard one actually. The standard unit for measuring angles is radian. Okay, for measuring plane angle is radian. Radian is the unit for measuring plane angle. The symbol is RAD. Okay, and similarly we have solid angle. How to visualize this solid angle? Okay, yeah, it is little difficult to visualize,
but I can give you the idea of an umbrella. Okay, if you open up an umbrella, okay, you get certain angle here, right, in 3D. Or you take a cone. Okay, when you take cone, you can get different angles based on the wideness of the cone. If the cone is too wide, the angle is more. If the cone is not that wide, short, then the angle will be less. That kind of angle is called solid angle. Okay, and the unit chosen to measure this solid angle is called steradian. Okay, steradian is the unit chosen for the measurement of solid angle, and the symbol is SR. Okay, so plane angle and solid angle are the only two supplementary quantities, with the supplementary units radian and steradian. Radian is represented by RAD, steradian is represented by SR. Okay, yes, that's about 3 class of units. In the next class, we will see few rules for writing units with examples and continue. Thank you.